طيب يا شباب. So let us continue with an example today. All right. Today we'll take an example. Probably also next class maybe we'll take one last topic. Okay. We'll talk about what's a thermodynamic cycle, and if we have time, we'll take an example, and then we'll be done with this chapter. Okay. So as I said, we'll continue with an example today, and this example is important, ya shabab. And I'm telling you from now, you might see similar example in the similar question in the midterm. Okay. So in this example, this is the following example here. So I have a system that consists of two tanks. Okay. Initially, so these two tanks are connected through a valve, as you can see here. Okay, so this valve connects these two tanks. Initially, this valve is closed, and each tank has carbon monoxide, but at different states. So tank one, let's call it tank one, which is on the left side. It has carbon monoxide at 77 degrees Celsius and 0.7 bar, and it has 2 kilograms mass. Okay. Tank 2, it has 8 kilograms of CO, or carbon monoxide, at 27 degrees Celsius and 1.2 bar. 1.2 bar. Okay, so this is the initial state. So when this valve is closed, these are the initial states of these two tanks. Now I open the valve, so the valve now is open, and the two gases are allowed to mix as I am adding heat. Yani while they are mixing, I am adding heat to the system. Okay, until the final equilibrium temperature. يعني خلاص they reach a final equilibrium temperature and pressure. The final equilibrium temperature is 42 degrees Celsius. 42 degrees Celsius. I'm telling you that after they mix, they all reach a final temperature of 42 degrees Celsius. So the question now, using ideal gas model with constant CV, okay, CV اللي هو ايش؟ اللي هو specific heat at constant volume. So using ideal gas with constant specific heat, determine I want the final equilibrium pressure and I want the heat transfer for the process. Okay. So again, I need the final equilibrium pressure as well as I want the heat transfer for the process. So this is the question now. I'll give you maybe like 5 minutes or 7 minutes to think about it, and then we will continue. So try it, please, ya shabab. Think about how we can proceed and solve this problem. Okay? Yalla ya shabab. This is important. Please, go ahead. How can we find the final equilibrium pressure where all the gases are mixed and they are in equilibrium? Yeah, shabab. I'll give you, as I said, 5-6 minutes or 7 minutes. Remember, this is ideal gas with constant specific heat. If you have a question, let me know. شباب كيف الوضع؟ I hope everyone is trying this. طيب شباب let us go through it together. شباب anyone؟ يلا شباب. anyone؟ hello. شباب معقولة يعني ولا واحد؟ تسمعوني يا شباب ولا نايمين ولا؟
معك يا دكتور.
أسمعك يا دكتور.
معاك دكتور.
طيب how can we solve this؟ شباب كذا ترى والله تزعلوني صراحة. يعني ما أدري وش قاعد يصير يعني. going on؟ شباب انتم عارفين ان الفهم في الكلاس مرة مهم يعني. قضية انك تفهم برا الكلاس هذا انت قاعد تضيع وقت يعني. ما انتم فاهمين يعني how we can proceed؟
راح أنا والله من فاهم.
وش اللي ما انت فاهم؟
ايديال جاز مود.
وش الايديال جاس مود؟ ما تعرف شو الايديال جاس؟
البي في ناتي.
طيب PV equal MRT وش فيها هذه؟ هذا هو الايديال جاس يعني مود.
Doctor, we are going to use this equation to solve, right?
I didn't know how to find the common pressure after the valve is opened, and also the volume. The volume it might be constant and cancelled, but the pressure and temperature, the initial, I couldn't find them.
طيب ما هي مشكلة. We will look into that. يعني I can show you. لكن in general يعني at least you should have an idea of what you can use. أنا قلت لك this is ideal gas model. Okay, لما أقول لك ideal gas هذا equation or this one PV specific volume RT, this can be applied at any state. خلاص, this is ideal gas. I can apply it state 1, state 2, initial state, final state. At any time I can apply this equation. Okay, so now we want the final pressure. طيب أنا قلت لك إنه final pressure and temperature are the equilibrium pressure and equilibrium temperature for both tanks. يعني two tanks they mix, they all reach the same final temperature and pressure. Okay, فمعناته احنا نتكلم عن ايش؟ لما نتكلم عن PV equal MRT، ولما أقول لك you can apply it at any state, so I can apply this at the final state, final volume, final mass, R, and the final temperature. بكل بساطة I can apply it like this. الفاينل volume وش هو؟ What is the final volume?
Take the volume of the two tanks together.
The volume of the two tanks, so the summation. Like what about the mass? Final mass?
Summation of their mass
is also the summation of both mass. بكل بساطة. يعني basically my system becomes these two tanks together. Okay, this is my system. يعني كأنهم صاروا tank واحد. You have summation of the volume and you have summation of the mass. That's it يعني. Okay. طيب الحين معناته I can find the final pressure like this. So basically, what is the final volume we said? It's M1. I'll call now 1 and 2 refers to each tank in the initial state. So the final mass is M1 plus M2, which is mass of the tank 1 plus mass of tank 2 times RT final divided by V1 plus V2, which is the volume of tank 1 plus the volume of tank 2. طيب السؤال الحين, what is the volume for tank 1 and volume for tank 2? Can I find it?
Yes, you can find it. Apply the equation in each tank individually.
Exactly.
Yes.
I can apply the ideal gas for each tank in the initial state. So this becomes M1 RT1 over
P1.
P1. The same thing applies for tank 2. I have M2 RT2. Remember, this is now the initial state, P2. Okay, so I can use the initial data here to find the volume, the volume for each tank, and then I can find the final pressure in this way. Okay, so I can actually write this equation in the final pressure. So let me write it like this. Final pressure is basically M1 plus M2 RT final divided by okay, you have M1 RT1 over P1 plus M2 RT2 over P2. I can cancel R here, I can take a common factor, cancel it with R there. Then the final pressure becomes M1 plus M2 T final divided by M1 T1 over P1 plus M2 T2 over P2. That's it. This is how you calculate the final pressure. في أي سؤال هنا؟ Is this hard? واضح يا شباب؟ So I can plug numbers. So I have 2 kilograms plus 8 kilograms. I have 42 degrees Celsius plus 273. How much is that? So 2 and 3 is 5. 4 and is 15. So this is basically 315 Kelvin. Remember, in this formula, when I use temperature in any equation, I use the Kelvin temperature. So this is 315 divided by, I have 2 times T1 is 77. So 77.273. You have 280 plus 70. So 350. 350 Kelvin over P1, which is 0.7 times 10 to the 5 Pascal, plus 8 kilograms. I have 27 degrees Celsius, plus, so this is 300 Kelvin, divided by 1.2 times 10 to the 5. So this becomes, the final answer I can give you here is 1.05, I think. Let me double check. Yes, 1.05 times 10 to the 5 Pascal, which I can write as 1.05 bar. Okay, this is the final pressure. This is the final pressure. You see how I used for the final state, I used the 2 tanks as one system. For the initial state, I used each tank as a system. Okay, this is how you can work and apply the equation of state, the ideal gas equation of state, to each state in this problem. أي سؤال على هذه؟ Any question about this procedure?
When did we use the CV? Because in the question we're asked to use the ideal gas model with constant CV.
It will come. It will come now. I will show you. For the second.
Okay, thank you.
طيب كيف نقدر نحل السكند بارت؟ How can you evaluate the heat transfer?
with the first law.
Okay, so we apply. شباب الهيت ترانسفير أعطيكم إياه من الأخير، ما في إلا طريقة واحدة اللي هي الفيرست law. Okay, in order to evaluate heat transfer ما في إلا الفيرست law of thermodynamics. Okay, so apply the first law. It's delta U equals Q minus W. طيب وش الورك هنا في السيستم حقي الاكزامبل هذا؟ وش الورك؟ How much is the work?
Zero.
No, you integrate B over dV.
طيب P dV. وش التشينج حق الفوليوم؟ Did I apply any work here?
Yes, the volume changed from one tank to the common volume of the 2 tanks.
طيب ممتاز. The volume changed, but did the gas apply any work? أنت طيب أنت كأنك تقول إنه الغاز expand, which I agree with you. لكن did the gas apply any work, or there was any work applied to the gas?
No.
No, this equation applies for what? This is not for any volume change. This is for expansion or compression work. Yani I'm applying work to expand the volume or contracting work. This here, if you notice, ya shabab, when I open the tank, it's not like the gas, there are already two gases, they were mixing, okay? And they were expanding naturally, yani they are not applying any work, they are expanding naturally and they're mixing together. So there is no any work applied during this process. فبالتالي the work here in this case, you cannot apply this equation. There is no work. هذه واضحة ولا مي واضحة؟
Yes.
Okay, you need to look if there is any work, if the gas did any work on the system or on the boundary or vice versa. Okay, so the work is zero. So basically, the heat transfer is the delta U, which I can write as U final minus U initial. طيب السؤال الآن يا شباب. Let me write it actually above here. So Q equals U final minus U initial. طيب السؤال الحين, what is U initial and what is U final? Huh? What is the internal energy initially of the system and what is the internal energy at the final state? So again, if you look at this system, the final internal energy is for the total mass of the gas, and the initial internal energy of the system عبارة عن initial internal حقة the first tank plus the internal energy of the second tank. So how can we write it here? So the initial internal energy is for each tank separately, so it's M1 U at T1 plus M2 U at T2. Okay, so this is the internal energy for the first tank and زائد the internal energy for the second tank. Okay, so this is for the whole system. But what about the final internal energy? It will be for the total mass at the final temperature. So basically عبارة عن ايش؟ عن M1 plus M2 times U at the final temp. وضح الفرق يا شباب؟ وضح الفرق هنا في الانترنال انرجي؟
Yes.
في أي سؤال عليه؟ Any question? لأنه الإيكويشن الأساسية حق اليو is M small u. Okay? M small u. So this is how we can write this.
ايوه دكتور، بس كيف حتجيب اليو اوف تي؟
كيف
حتجيب اليو اوف تي؟
الحين بنجي لسالفة اليو. Okay? طيب let's write it again. So let's write Q. So Q equals to what? Let's write this M1 plus M2 U at T final minus M1 U at T1 minus M2 U at T2. Okay? If you open this one, يعني إذا نفتح القوس هذه ونرتب الأترام, يعني arrange the terms to have the masses as common factor, I will end up with M1 times U at T final minus U at T1 plus M2 U at T final minus U at T2. Okay? اوكي شباب, هذه بس مجرد انه تفتح هذه, so M1 U T final plus M2 times U T final minus M1 UT1 minus M2 UT2. If you take M1 and M2 as common factor, you end up with this form of the equation. طيب السؤال الحين وش قال؟ قال using ideal gas model with constant specific heat. Okay? With constant specific heat. For constant specific heat ideal gas احنا وش نعرف؟ نعرف انه delta U equals ايش؟ CV delta T for ideal gas with CV equals constant. Okay? So for a constant CV, if you have an ideal gas with constant specific heat, I can rewrite the change in the internal energy as CV times the change in temperature. Okay? And this is the idea behind this question here. So basically I can rewrite this as M1 times, now I will use an average CV, okay? I will use an average CV between T1 and T2. ليش؟ لأنه أنا أعرف إنه T1 350 و T2 300, okay? و T final is in between, so I will find an average between the 300 and 350. So the CV, an average CV between 300 Kelvin and 350 Kelvin. So let's write this one here, and I will show you in a minute what I mean. So let's say this is CV average times, now this is U2 T final minus UT1, so I can rewrite it as T final minus T1 plus M2 CV average T final minus T2. اوكي طيب وش السي في افريج الحين؟ what do I mean? the CV average الان if you go يا شباب to the tables, let me show you here, and this is the idea in this question. ركزوا معي يا شباب لانه هذا السؤال بيجيكم شيء شبيه له في الاختبار. I'm telling you from now, okay? Similar question might come in the midterm. الفكرة يا شباب انه في table A20, if you go to table A20, or yes, this table here, okay? So in this table, you see يا شباب that this table gives you ideal gas specific heats of some common gases, okay? فيعطيك السبيسيفيك هيت يا شباب، يعطيك السي بي، يعطيك السي في، يعطيك السبيسيفيك هيت ريشيو اللي هو الكي، okay, for different gases. عندك air، عندك nitrogen, oxygen, and also you have carbon monoxide, which is in our case this is our problem, okay? فعند كل temperature you have a temperature, and for each temperature a corresponding specific heat. ممتاز. فأنا عندي two temperature، عندي 300 وعندي 350. 315 comes in the middle, so I can use an average temperature between 300 and 350, or average specific heat. How do I do this? I come here and say, so from table A20 at 300 Kelvin, I have CV equals, let's look at it here. So at 300 Kelvin for carbon monoxide, I have 0.744, 0.744. What is the unit? It's important. It's kilojoule. If you go up here, you'll see it's kilojoule per kilogram Kelvin. So kilojoule per kilogram Kelvin. At 350 Kelvin, I have CV as 0.746 kilojoule per kilogram Kelvin. Okay, فبالتالي CV average is simply 0.744 plus 0.746 divided by 2, I get 0.745 kilojoule per kilogram Kelvin. Okay, so this is how you find when the question tells you use a specific heat at average temperature. This is how you can do it. Okay, so you take 300 Kelvin and find the specific heat, and then find it at 350, and then take the average. This will be at average, sort of an average temperature. Okay, that's it. خلاص. Now I can rewrite my problem or substitute numbers. I have M1 is 2 kilograms times 0.745 is the CV. The T final is 315 minus 350 plus 8 kilograms 0.745, and I have 315 minus 300. Okay, so if you do the calculation for this, you will find that the final answer here, Q is it's gonna be plus, you see here, it's gonna be plus 37.25 كيلو. واضحة الفكرة يا شباب؟ لما يقول لك use a constant CV, when the question tells you this is ideal gas with constant CV or constant specific heat, sometimes I say specific heat, you take CV delta T. Delta U becomes CV delta T. How do you evaluate CV? ممكن السؤال شباب هذه في الهوم ورك ترى على فكرة برضو. تذكرون الهوم ورك؟ حليتوا الهوم ورك الباقي؟ في الهوم ورك برضو في سؤال شبيه لهذا. You can evaluate CV. ممكن السؤال يقول لك evaluate CV at T1, ممكن at T2, ممكن at T average. Okay? So the way I did it here is T average. Alright? And then that's it. I evaluate the CV delta T for each case, for example, in this problem. أي سؤال هنا يا شباب؟ وضحت how can evaluate the heat transfer for ideal gas with constant CV?
واضح.
طيب لو قلت لك evaluate the heat transfer with variable CV. Find heat transfer for variable specific heat. What would I do? ها شباب؟
integrate CT DT.
Integrate.
integrate ايش؟
CV DT.
قصدك الدلتا يو يعني بسوي
Yes,
سي تي.
delta U is equal to integration of CV DT.
طيب ممتاز. معناته ايش؟ معناته دلتا يو السي في is a function of temperature. صح؟ حلو. So this is one idea is to have an equation for the CV as a function of temperature and then integrate and find the answer. The good news is, the good news انه the tables, if you go to the tables, there are tables start from table A22. Okay? So A21 يعطيك CP as a function of temperature. لكن CV there is no equation. بس the good news is إنه I have tables. If you look at this table is for air. It's ideal gas properties of air. For each temperature يا شباب, I give you what? The table gives you the specific enthalpy, the specific internal energy, the entropy. Okay, we'll talk about entropy in the future. فالvariable هذا التيبل يا شباب, they did it for variable specific heat. يعني the specific heat already يعني it's a function of temperature, and the effect of it on the property is already evaluated in this table. Okay, so this is kind of the more accurate way, or the more accurate, or the more actual values for the properties as a function of temperature for the ideal gas. فبالتالي هذا A22 is for air. There is other table here, you can see it's A23. This one is for multiple gases. For multiple gases, and it gives you in the molar basis. Molar basis يعني ايش؟ يعني this is kilojoule per kilomole Kelvin. But you can use ايش? You can use the molecular weight to easily convert to mass basis, right? So let's look at here. This is carbon monoxide. All right. I have 300 Kelvin. I can find U at 300 Kelvin. I have 350. I can find U at the 350. And then the T final is 315, and I calculate here to find the value for 315 Kelvin. And then, and since this is in the middle, yani I can just take an average between 310 and 320. Okay, so let us actually do this. So Q will be simply, we're gonna go back there. Q is gonna be M1 U final minus U1 plus M2 U final minus U2. Okay, so table, this is from table A23 at 300 Kelvin. I have U, this is U2, right? It's gonna be, let's see it here. So at 300 Kelvin, I have carbon monoxide. I have 6229. This is 6229 kilojoule per kilomole Kelvin at 350 Kelvin. I have U1 equal, go back here. So this is carbon monoxide, this is 350, 7271 kilojoule kilomole Kelvin, and at 315 Kelvin I have U final equals, so let's go back. So this is the average between this one. Let me calculate it. 6437 plus 6645 divided by 2. It's gonna be 6541. This is 6541 kilojoule kilomole Kelvin. Okay, how can we find it in kilojoule per kilogram Kelvin? We go to table what? We go to table A1. Ya Shabab, you have to be familiar with the tables. You immediately go to the correct table without wasting time. Okay? If you go to carbon monoxide here, you see that the molecular weight is 28.01 kilogram per kilomole. Okay? So this is 28.01, right? Carbon monoxide 28.01. Okay. So what I do is
divide.
That's exactly. So what I do is I divide each one by 28.01. So 6229 divided by 28.01 gives you 222.4 kilojoule per kilogram Kelvin. 7271 divided by 28.01. This is 259.6 kilojoule kilogram Kelvin. And last one, 6541 divided by 28.01 gives you 233.5 kilojoule per kilogram Kelvin. That's it. Now I have everything. Okay, I have everything in terms of mass basis. Simply now Q becomes 2 kilograms. I have 233.5 minus U1, which is 259.6 plus 8 kilograms times 233, the same, minus U2, which is 222.4. تتوقعون تكون بعيدة ولا قريبة؟ ها؟ What do you expect? 3.5 minus. Is it gonna be very far from the first method? Minus. So this gives you a value of plus 336.6 kilojoule. Okay, so there is slight difference. So this is 37 and this is 36. Again, which method is more accurate يا شباب؟ المفروض
Second one, I believe.
the second one, because the CV is a function of temperature, okay? And the tables gives you the actual properties as a function of temperature for the ideal gas. Okay. وضحت يا شباب؟ واضح؟
واضح.
Yes, واضح.
All right. So that's it. Any questions? Any questions? Right. طيب يا شباب. خلاص, if you don't have any questions, you're free to go. هلا.
يوم الخميس
صوتك بعيد ترى ما اسمع.
الحين قريب الصوت.
ايه كذا كويس.
يوم الخميس انقطع عندي النت في وقت التسليم، فلا الطابعة اشتغلت معاي ولا شيء، فعلى ما شبكة الكمبيوتر على الجوال اللي كان باقي يمكن 10 ثواني ويخلص التسليم، فرسلتك على الإيميل.
طيب I'll check the time, it's fine.
اوكي شكرا.
بارك يس.
السلام عليكم.
نعم.
الدكتور بالنسبة للكويز وقت التسليم بلاك بورد سمح لي بس أسوي سبمت لصورة واحدة وأنا حلي كان بصفحتين.
طيب ارسلته بالايميل على طول؟
إيه أرسلته على طول بالإيميل.
خلاص اوكي no problem, I will check.
تمام يعطيك العافية.
يلا شباب بالتوفيق و see you later.